Okay, so we're going to look at transforming quadratics. This is known as a parent function, but instead of me telling you exactly what these are, we're going to look on a graph at specific versions of them, and we're going to develop our own 3 rules for these extra variables in our quadratic. Okay, and normally a regular looking quadratic would technically look like this: y equals x squared. This is a quadratic function. Okay, and we'll talk about what the k, h, and a are actually in that version. So we're going to bring up a graphing calculator here. Okay, so I have a graphing calculator, and as you see, we've done k to start. Okay, and right now the k value is 1. That's what this reads. And what's neat about this program is I can slide it up and down. So as I increase the k value, what's happening to this parabola?
It's decreasing.
It's going up.
Yeah.
Right? As I bring it down, what's happening to it?
It's expanding, like it's going lower to be negative. It's going down.
Yeah. So I want you to think of it like this. This is known as the vertex.
Yeah.
That vertex, see what's happening? The vertex is going down as we go down. And look, at negative 7.1, the vertex is at negative 7.1. And as I slide it up, when I move it to 3, whoops, I went to 2.9 there. When I move it to 3, the vertex is at 3. So what would we say the k value does? When we make it positive, what is it doing to this? What is it doing to this?
It's going up.
Yeah. And when we make it negative, what's it doing?
It's going down.
Exactly. Okay, good. So let's make our first rule for that. Over here, we're going to say that the k value, okay, it vertically transforms it, moves it up and down. So what we'll say is when k is positive, it goes up, and when k is negative, it goes down. Okay, so we've made up a rule for k. So that's the first one we've done. Okay, so we've checked, we did this version.
Yeah.
Now let's do this version. We're going to try to figure out what h
k
does.
Goes up and down.
Yep.
And when k is positive, it goes up. K negative goes down.
Exactly. Good. Okay, here's the next one.
Oh, they print this off again. Yeah.
Exactly. Here's the next one. So, in this version, we have an h. And if you notice the h, okay, the h value here, there's technically a negative in front of it. So right now, if I were to actually type that in, that says x negative 1. It's hard to see in this version. Okay? So, I want you to think of it like this. And maybe I should do, well, we'll show it to you this way. I'm gonna show you a good way to think about it. See, as this version here, this is actually, if I was to put it in the equation, it'd look like x negative 2. And if you watch the vertex, what value is it at? What's the x value?
2.
Positive 2.
Positive 2.
Okay? So because there's a negative in front of that, and what I mean by a negative in front of that is you see this negative in front of that h there?
Yeah.
Okay? Technically, this says x negative 3.7. So it looks like x minus 3.7 if we were to actually put it in there. Okay?
Yeah.
So with that being the case, as the negative gets greater and greater, it's going to the right. Okay? And as we see now, this is the tricky part. See, because it says negative h and negative 1.4, you got to know your integer rules here. So the idea of this is x minus negative 1.4. Do you know what we do when we have a negative of a negative?
Make it a positive?
Yeah, so it's x plus 1.4. That's what this says right now. Okay? So when it's positive 1.4, what are we getting as a value here for a vertex? Is that a positive or a negative?
Negative.
That's a negative, right? So when this is positive, this is negative. So it's kind of making a double negative at the moment. Okay,
Yeah.
I know it's hard to see that idea here. We see as we do that, it slides this way. Okay, and I'm going to turn that off and just show you a new version.
H?
That's the h.
So h goes horizontal along the x-axis?
Exactly. So let's think of it like this. Put negative 6. Where's the vertex? It's at
6.
positive 6.
Positive
And
6.
see how it looks like a
Yeah.
negative in there?
Yeah.
And if I were to change that to positive,
It'll end up on that
the
side.
vertex is at a
Because
negative.
when
So,
it's a positive, actually a negative. When
Yeah.
it's a negative, actually positive.
exactly. So it
Ah,
kind of looks like the
tricky.
opposite. So our h moves things what direction?
Horizontal along the x-axis.
Yeah, right. It moves it horizontally. So I'm going to say left and right. Okay. Yeah. And the idea is here, I want you to think of it more like the actual number. So as if you're looking at the whole thing as a number.
Yeah.
H, when it's negative, goes to the right.
And when it's really negative, it's positive.
Yeah.
And, it's
And
really
when
positive, negative.
when it looks like it's positive, it goes to the left. Does that make sense?
Yeah.
It's kind of counterintuitive because technically the right is a
See it,
positive
like,
direction.
on like what you were showing on the calculator,
Mhm.
say if it was saying like x take away h, it'll actually be x plus h.
Yeah, well,
on
the vertex
graph,
is at,
like
yeah.
when you do it.
It's at positive 8 on the graph. Positive
Yeah.
8 and 0, okay? So we've done these two. The last one we're going to look at is A. And A has kind of a couple rules we got to look at, okay? So let's look at A. We'll turn this one off. And here's my version for A, okay? Right now, A is 1. And the vertex stays there. And what you're going to notice is the vertex is not going to change. But a couple other points are going to change. Like, I wish I could, there we go. This is at 1 and 1, okay? This is at negative 1 and 1. As I move the A value to greater positive numbers, what's happening to this?
It's coming inward, like shrinking in.
Yeah.
I know it's not stretching, so the compress is really compressing.
Technically, they call this a stretch, okay? Even though it looks like it's being squished from the sides,
Yeah.
I want you to think of it like elastic band. And if I had an elastic band and I pulled it from the top and from the bottom, the elastic band would start to look really long like this if it was being pulled from the top and the bottom. And that's known as a stretch. Yeah, that's supposed to be an S there. That's known as a stretch. I know it kind of looks like it's squishing in.
This is a stretch?
Yeah.
So this would actually be a stretch?
That would actually be a
because going
stretch.
upward kind of when it
Yeah,
stretches?
like an elastic band being pulled up. And watch what happens. Oops.
So it's compressed.
Turn it off. And when I bring it down, and specifically when it's between 1 and 0, so watch, when I get to these decimals here, what's happening?
It's becoming compressed. Is that
Yeah.
what compressed is?
It's coming
Going up?
compressed, that's right.
Next. Like
Yeah.
that. Oh.
So as you see, it's a decimal. This is where they call getting compressed. And I want you again to think about it. If it was an elastic band, and I was pushing from the top and the bottom, it would get really wide, right? And that's the idea of compressing from the top and the bottom. So as we become, I'll delete that part.
Can you show me compressing one more time? Like what it
Yeah,
looks
so this
like?
is compressing. See how it's getting wider and wider? And this is stretching.
That's stretching
Thinner and thinner.
Oh,
Always
okay.
think as the pressure coming from the top and the bottom. Now, I want to show you something very specific here. See, as A gets closer to 0,
Yeah.
okay, and then when it's
Oh.
negative, what happens?
It flips and goes negative underneath, so then it gets compressed going down, and now it's stretching going down.
Yeah, so now it's stretching going down because the A value is getting greater and greater. And as it gets closer to 0, it's becoming compressed, but the only difference is it's facing downwards.
Yeah.
Okay?
Oh, facing downward. That's the
Oops.
facing down.
Yeah, so let's take a look. So A's kind of got two rules for us. Okay? What's going to happen with A, we'll kind of write it down here. A does two things. When it's positive, I'm going to say it opens up. Okay?
Yep.
Kind of has this effect. Okay? When A is negative, it opens down. So it kind of does this. Okay? And as A's, the best way to put it as when A is greater than 1, it stretches.
It is greater than what it's stretching.
Yeah, and then
Yeah,
that's where it gets, I guess I'll try to draw it really thin like that.
Yeah.
Okay? And when A is less than 1 but greater than 0, so when we're in those decimal numbers, it's compressed.
And so that would look stretch upward, right?
Yeah, and this is what compressed looks like, really wide, like a happy mouth.
So what if that was a negative one? If A is
And if
greater
it was,
than...
so like I'll show you again. Same idea. So yeah, negative 0.3, it becomes really
Oh, it just
compressed,
starts-
right?
It just goes down when it's negative. And
exactly.
It's up, it's positive.
And
But
as
the
the-
direction of opening still
Yeah.
the same.
So the negative and positives tell us which direction. The absolute value of the numbers tell us if it's stretching or compressing. Okay, so with that being said, let's kind of look at all of them together very quickly. Oops. And we always do f at x, so equals a x minus h part of 2 plus k. So here's our blue guy here. Okay, and I'm going to make my a value 1. I'm going to turn that guy off. So let's turn. Okay, so zoom out a little. Here's the vertex, right? We know the k value, as we move it up and down, it does this. The h value, left and right, okay? And the a value goes up and down. Does that kind of make sense as a set of rules?
Yeah.
Yeah.